Exponential models bookwork, page 7, number 6. The temperature T of a cup of coffee is given by the function T equals 18 plus 60 times 2 to the negative T, where T is measured in Celsius and T is in, well, capital T is measured in Celsius and small t is measured in minutes. Sketch the graph from 0 to 10. 0 to 10. So that would be about here to here. 5. So the first thing we're going to do is we're going to graph it because we just have an equation. If we have an equation, there's no reason not to graph it. Graphing is always going to give us a little bit more information really easily, just for free. Negative. Okay. Then we do second table. Okay. So let's see, look at our values from 0 to 10. So we start at 78. And then 1 would be 48. About 5. At 5 it would be 19.875, which is 19.9. And what about at 10? The value of 10 is 18. Okay, so let's say that the top of this is 100. So 0, 78, that would be about here. 1, 48. So this would be 1, 2, 3, 4. Okay, so 1 would be 48, be about there. 5 would be 19.9, would be about there. And 10 would be 18, about there. Okay, so let's try to draw that exponential curve. Okay. Okay, sketch the graph we just did. Write down the temperature of the coffee when it is first served. Let's see, this is the temperature of the coffee. It starts out at 78, and then it drops down gradually, and the asymptote is 18. Okay, write down the temperature of the coffee when it was first served. So I guess that would be this, 78 degrees. That's when T equals 0. Okay. Find the temperature of coffee 5 minutes after serving. Well, I guess that would be T equals 5. So that would be, let's see, 19.9 degrees Celsius. Calculate the number of minutes that it takes the coffee to reach a temperature of 40 degrees. Okay, so that looks like it would be somewhere between 0 and 1. It reaches 48. Oh no, I'm sorry. It reaches 40 degrees after 1 minute. Let's see exactly how many minutes afterwards. See how useful it is to graph. We're getting answers to things we didn't even know we were supposed to answer yet. So let's see, between 1 minute and 2 minutes, it crosses 40 degrees. So maybe we could say, let's see, how does it ask it here? It says calculate the number of minutes that it takes for the coffee to reach a temperature of 40 degrees. Well, between 1 and 2 minutes, let's say 2 minutes. That says write down the temperature of the room where the coffee is served, give a reason for your answer. Okay, so the asymptote approaches 18 Celsius after 10 minutes. And after, you can see that the temperature hardly changes. You can see it's just like getting closer and closer to 18, but, now it finally gets to 18, okay? So usually if you have a hot cup of coffee and you leave it in the room, after a while the coffee is going to be the same temperature as the air in the room if you leave it there long enough. So I would say that the temperature of the room is 18 Celsius, and the reason why is because the horizontal asymptote is 18 Celsius, okay? All right, now let's go down to number 8. The graph of the function f of x equals 2 to the x over 8 passes the points 0b and 2, comma 0.8. Calculate the values of a and b. We're going to write down these values here, 0 and b and 2, comma 0.8. Okay, let's see if that helps us. We have the function that's equal to 2 to the x divided by a. So we'll put in the first value, we'll put in x equals 0 and y equals b, and we get b equals 2 to the 0 over a. 2 to the 0, of course, is just the same as 1, because anything with 0 is 1. X equals 2, let's see, y equals 0.8, so that would be 0.8 equals 2 squared over a. Okay, so it looks like we're on our way to finding a at least. Look, we have 0.8 equals 2 squared, which is 4, over a. If we multiply both sides by a, we get 0.8a. And then the a's cancel out there, it equals 4. So that would be a equals 4 divided by 0.8, which is 4 divided by 0.8 is 5, I think. Okay? So a is equal to 5, and now that we know a equals 5, now we know b. It's 1/5, 0.2. Okay? So b is 0.2 and a equals 5. The last problem in the exponential models book work is page 8, number 10. A function is represented by the equation f of x equals 2 times 3 to the x plus 1. Here is a table of values f of x for negative 2 to 2. Calculate the values of a and the values of b. So we're supposed to calculate that and calculate that. Draw the graph of f of x for negative 2 to 2. The domain of f of x is real numbers. What is the range? Well, we have a complete equation here. So, as we always do, first thing we want to do is type it in the calculator. Why not? This is going to give us, like pretty much every point on it. Plus 1. Okay. Second table. Okay, and then we're going to look, we're particularly interested in the region negative 2 to 2, so we'll go to negative 2. So the smallest number is 1.222, that matches here. Negative 1 is 1.6667, so A is actually 1.67. 0 is 3, that matches. 1 is 7, that matches. And 2 is 19. Okay, so we already have the two values for A and B. That was A. Draw the graph for negative 2 to 2. Negative goes from negative 2 to 2. We already have these points here, so not too hard. We just make a huge graph because we got a lot of space, and we know we need to graph between negative 2 and 2. So 0 would be 3. 1 would be 7. 2 would be 19, so that would be like way off the screen here. And on the other side, negative 1 would be 1.67. And negative 2 would be 1.22. Okay, so let's graph that. Okay? Alright, so that was that. Now the domain of f of x is the real numbers. What is the range? Okay, well, if we, it's kind of weird. I think I just kind of made a mistake when I graphed this, because the height of here is 10. That would be about 19, right? This would be about 5. And I was supposed to graph 1.22 and 1.67, and you can see I went too low. 1.67 would be about there, and 1.2 would be there. Okay, so sorry about that. The asymptote should be, 2 or a 1, so that's why I thought it was kind of weird. Okay, the asymptote should be 1. Okay. The domain of fx is real numbers. What is the range? Well, if the domain is the real numbers, then the range should be whatever the exponential function reaches on this end and whatever reaches on this end. Well, on this end, it'll never touch 1, right? So it's always going to be above plus 1. So one of the limits is y is greater than 1. And what about the upper limit? Is there an upper limit? No, because if we go steadily out to infinity here, this is also going to go steadily out to infinity. So there is no upper limit. There's only a lower limit. So the range is going to be y is greater than 1, or f of x is greater than 1. And that is the last problem that we were going to show the solution for.